Hello friends, welcome to our YouTube channel. So let's to be continue with this amazing effect, that is photoelectric effect. So the next point, it is Einstein's contribution for the photoelectric effect. So Einstein developed an equation which will depends on this effect, that is called as the Einstein's photoelectric effect, and amazing is that he got the Nobel Prize for this effect. Okay, so let's see what is this effect. So starting with the previous concept, Planck's hypothesis. So what is Planck's hypothesis? The energy of a photon, because in photoelectric effect, photon plays an important role. So that photon has energy according to Planck, it is h into nu, where h is the Planck's constant and nu is the frequency of the incident radiation. Okay, so E is given by, E means energy of the photon, it is given by h nu. Now according to photoelectric concept, these photons transfer their energy to the electrons, and these electrons, after absorbing this energy, they will emit from the surface. Okay, so during this process, this energy is utilized by the electrons. Now according to Einstein, this energy, photon energy, it is utilized by two ways. The first way, it is the photoelectric work function. The energy required to emit the electron from the surface, this is work function. Okay, so it is nothing but the minimum energy that is required for an electron to emit from the surface or removing the surface. Okay, so this energy, it is less from the photon energy, means one way it is used for the emitting of the electron. The remaining amount of energy, if it is not utilized or it is not wasted for any other type of the activities, then the total remaining amount of energy is nothing but the kinetic energy of the electron. That means if the electron will not lose the remaining amount of energy, what is the remaining amount? H nu minus W. W means it is the work function. H nu photon energy and work function. The remaining amount, if it is not lost for any other work, then the remaining energy, it is the maximum kinetic energy, and this kinetic energy is for that electron that is moving, and motion of the electron, that means the current. So it produces the current. Now let m is the mass of the electron, small m, it is the mass of the electron, and v is the velocity. Then kinetic energy, according to the basic concept, it is given as kinetic energy is 1/2 mv square. Okay, so actually here energy of photon according to this equation, it is divided, so it is equal work function, photoelectric work function plus kinetic energy of the electron. So it is represented as equation this number 1. H nu is equals to W plus 1/2 K, it is represented as H nu is equals to W plus 1/2 mv square. Okay, now we have to just simplify this equation and we will get the concept. Now here H nu minus W represents the maximum kinetic energy, because if we shift in the equation, the remaining is nothing but the kinetic energy. So H nu minus W is maximum kinetic energy that required for electron, photoelectron, to move in the forward direction. Okay, so we can represent this equation by changing velocity to be maximum. H nu is equals to W plus 1/2 mv max square. This equation, basically it is known as the Einstein's photoelectric equation. So this is the first concept he gave and the first type of the equation. There are various methods to represent this equation, we will see that, but this is the first concept we get here. The equation which is represented here, it is Einstein's photoelectric equation. Now according to this equation, what is nu? Frequency. What is h? Planck's constant. And we know that one more concept we are going to apply here, the threshold frequency. In previous class we have discussed that threshold frequency means what? minimum frequency required of incident light at which the emission will start. Means at the starting position, the emission when just start, the frequency it will be nu naught. Okay, so that is threshold frequency. So we will apply this concept in this equation number 1, and we will get here the second equation or the second format of the equation. So work function means what? Work function means energy required to just emit the electron, and here threshold frequency means what? Minimum frequency required to emit the electron, means here they both are related. So this is given by, again Planck's concept, we are using energy is h into frequency. So energy here, work function W, it is equals to h into frequency is nu naught. So this is the value of work function. Actually work function we can calculate by using this concept. So substitute this in equation number 1, we will get the second format of the Einstein's equation. Okay, so let's substitute. What is our basic equation? That is h nu minus W. So we will substitute here h nu minus h nu naught. And what is RHS? It is 1/2 mv max square, that means kinetic energy. So according to this, h is common in the LHS, so take it common. H in the bracket nu minus nu naught is equals to kinetic energy 1/2 mv max square. It is the another form of the Einstein's equation. H into nu minus nu naught is nothing but the Einstein's equation. Okay, so there are two formats as we discussed previous. It is h nu minus W is equals to 1/2 mv square, and second is this h into nu minus nu naught, where we introduce the threshold frequency, and it is again the kinetic energy. Okay, so hope you understand what is his contribution, and from this equation we are able to see observe that, or we can conclude which frequency will produce the photoelectric effect. If we are focusing a light of a frequency, suppose it is 5400. Okay, so sorry, it is wavelength. So suppose the frequency it is 550 hertz. So this frequency, if it can produce the photoelectrons, then this equation has the positive kinetic energy value. Nu minus nu naught, incident light is nu and threshold frequency is nu naught. So whenever nu it is greater than nu naught, then only we will get the positive kinetic energy. Means our condition for photoelectric effect will satisfy minimum frequency required to emit the electron. So when nu it is greater than nu naught, then only it will be possible to get the kinetic energy, means photoelectric current, that means photoelectric effect. So this is the Einstein's contribution. From the equation he deduced this condition. Okay, so hope you understand what is his formula, what is his equation, and what is his contribution. So if you have any doubt regarding this, please comment here. If you like our videos, share it and subscribe our channel.